Hey guys, how's everything going? This is Jason, who is not good at algorithms. In this video, I'm going to take a look at 1, 4, 8, 2, leftmost column with at least a 1. A binary matrix means that all elements are 0 or 1 for each individual row. The row is sorted in non-decreasing order. Non-decreasing means ascending or not. Yes, it should be 0 in the front and 1 at the end, right? It's not decreasing. Given a row sorted binary matrix, return row sorted. This is row sorted. Okay. Return the leftmost column. 0 based with at least a 1 in it. If such index does not exist, return -1. I cannot access the binary matrix directly. I may only access the matrix using an interface. Means get a row and a column returns the element. Dimensions return a list of 2 items, rows and columns, which means the matrix is rows and columns. Submissions making more than 1,000 calls to get will be judged wrong answer. Also, any solutions that attempt to circumvent. What does this mean? Circumvent. Circumvent, the judge will result in disqualification. So for custom testing purpose, we're given a binary matrix map as input in the following 4 examples. You will not have to access binary matrix directly. Yeah, okay. So we're given a matrix like this. So for each row, 0s have to be front. We need to search for the leftmost index of 1, right? Well, for each row, we can search the leftmost. Like for row 1, it will be here. Next one, it will be here. And next one, it will be here. Right? So actually, we could do, so for each row, it will be the binary search, I think. I think we've done several similar problems, like find the first bad version, and or do our own implementation of low-dash sort index. Please search on my channel for that. There will be detailed explanation. So actually, we could use binary search with log n, which is here log 100, to search for the first appearance of 1. Okay, so for the first row, we get index, and next one we could search till the next one, right? Till the first one. I mean, we know that the first one appears here at the first row, but so for the second row, we could just check if the one exists in the range here, right? If not, we go to the next one. So that will save us a lot of time. Yeah. So the idea is binary search for first one in each row, narrow it down. If there's no 1, we return 0. Well, no ones return -1. Okay, that's fair. Okay, so we create a function, which means to get a row, because this create a helper function, which will be called for each row. So let's call it get first one index. Okay, first index of 1, which means we'll get the row, which is row number, and the start always should be start from 0. We don't need start, so we got end, right? Start from 0. So I'll implement this later. So this will return the index or -1. Cool. So if it is -1, we'll just continue searching it. So let result equals -1. So for, okay, we don't know the rows. Oh, we know the rows. Okay, so const rows equals binary matrix get dimension which is get dimension. Cool. Now for let I equals 0, that's more than rows, plus plus. We will do it row by row. Okay, so okay, so we get the const index of 1. We call it by get this function, right? So this row is I. The n, well, this n must be from the previous one. So we say the n equals, first will be equals -1. We get the n, right? So for the first row, we search for all the elements and get the result, which is the index. So now if the one exists, we say result equals to it, right? If it exists, we set to it, and we will start searching for the next possible result, which will update the n to -1, right? We'll search the range here. We found it, so we search here, search the range here, and get it. Well, if we could just update a special case, if index 1 is 0, we could just return it, right? So it will not overflow our index. Even if it is 1, we could search from 0, 0. And yeah, so that's it. And finally, we will return our result. Now let's start to implement this one. Well, this is simple. It's binary search. Okay, I'll start equals 0, make n. Well, start small equal to n. We'll search for the first one. First appearance of 1. Okay, so the middle equals math floor start plus n divided by 2. We now get the middle, which is const middle index, const middle, this binary matrix, and get, which is row, and the middle index. Okay, if middle is smaller or, well, if it is 0, the next one might be 1, right? So we move it forward. If it is 1, the previous one might be 1, right? So we move it backward. So if it is more than 1, no. If it's only 0 or 1. So if it is 1, we will move into middle -1. If it is 0, we move start equals middle plus 1. So if we do this, the final case will be n at here and 1 n at here, right? See, like start n equals the same, n equals 1, n will be moved backward, right? And if they are at same at 0, the start will be moved to 1. So finally, the start will be the index. If there are no one, like the start and end at the first one is 0, then this end will be moved to -1. No, the 0 and the start will be moved to the next one, and it ends. The end will start at the the end. Wait a minute. if there is a 1, like for at the beginning, start will always falls here, and end will come to 1, and the middle is 1, so end will become the previous 0, right? If it is 0, like end comes to 1, start will goes to 1, and end comes to 0. So the problem becomes the start, whether it's 0 or not. So return matrix get row start equal, if it is 1, then we return start. If not, then it doesn't exist, right? So I think this should work. Let's try to review our code before we submit. Okay, for a case like this, we'll first get the row we get the dimension, and now for the start, like 0, 0, 1, we get 0. That's the middle. And get it is 0, so we move start to here. And now the middle is 0, we move start to here. The middle is 1, because 1 end move to 0. And the start, this is 1, so we return start. So first start will end, first index will fall as 3, like here. For each row, we will get it. So the index is bigger than it, so it's 3. So we update result to 3. The end was set to 2. So we will search 0, 0, 1 again. Start, middle, and start was set to 1. And then end will move to 0. So start is 1, so start. Again, 2. So we update to 2, end will be 1. So finally return 1. So it should work. Oh, it seems like we have an infinite loop. Yeah, we have an infinite loop. Where is it? There are some. Where is it? And start. So this will finally 4 start math 4. Seems okay. Allow me to log for the row. Seems no problem. Time limits it. What? Because this lock. The get first index of 1 has a problem. Row end. We move into the previous one and start moving forward. There's no problem. This seems no problem here. Hey guys, can you see what is wrong here? 0, 1, 1, 1, 1. Huh? Okay, 0, 1, 0, 1, and the middle is 0, so we move start to 1. And then both of them are 1. Middle, because it's a 1. A 0, so we will start. Oh, I made a mistake. Okay, so start. Start 1, 1, 1, 1. The middle is 1, so get it? It's 0. When it's 0, we start. Set start to 2, right? Why we stop at 1, 1? Okay, 0, 1. This is 0. Middle is 0. Get row, which is 0. So 0, 0. Middle. The middle index. Oh shit. Oh shit. I know what happened here. I'm stupid. I usually write middle, but today I happen to write the middle index and get the middle number. I'll just rewrite to make the usual way of I'm doing it. So the number like middle is be num. Yeah, I think this is stupid. Yeah, pretty stupid. Cool, we're accepted, but not that fast. Oh, it's not bad. Not that bad? Sometimes bad. Well, see if this is this what the best what I can do? Well, we cannot get the matrix directly. This is a binary search. We return it, and we loop through row by row, or this because the row we're not guaranteed to have a like a form of matrix like this, right? There might be ones at there might be they're not exactly they might be not exactly at the diagonal, perfect diagonal like this. There might be 3 ones here, 2 1 here, and 2 1 here. We cannot do binary search on this, or randomly we pick some rows. Yeah, no, I think this could be the best way I can think of. Let's try to analyze the time and space for this one. The time, well, it's I'd say rows. Oh, say this n rows and the log n, right? Space, nothing, so it's constant. That's all my solution. Let's see if we need anything. Linear search each row. Linear search row is not good. Binary search, yeah, this is binary search. Let's see what it done. Yeah, we did it, and then search here. We don't need actually search for this. We could just search till this, right? I think we're doing better than this one. Yeah, the same. I think we're doing the same. Cool. Okay. So yeah, that's all for this one. Hope it helps. See you next time. Bye bye.